Hey, what's up, everybody? Mr. Murray here, Mr. Murray's Mathland, and we're doing a law of signs video today. And the directions here are just going to say determine whether 0, 1, or 2 triangles exist with the given measurements. And so, in those ambiguous cases where you actually have to solve for all the missing parts, if it's 2 triangles, we're not focusing on actually finishing it off, just telling. How do you tell when there's 0, 1, or 2? Sometimes that's the trickiest part for people. So, and hopefully I'm going to tackle a variety of examples here and a couple different ways to tell, depending on how you like your work more, if you're a geometry kind of person and like to visualize, or if you're more of an algebra person and trust your calculations. So let's just jump right into it here. My first advice would always be either visualize or actually just draw a triangle and label it with the given information. So angles A, B, and C, we gave you that angle B is 74 degrees, side A, which is across from angle A, so that would be right here for me, 28, and side C, which is across from angle C, would be right here. And now hopefully you're thinking, hey, we're done, because I gave you two sides and the included angle, which means, the angle where the two sides meet. And if you remember back to the good old days of geometry, that's what we call side, angle, side. And if you have one of those, classic geometry postulates that are given to you, the whole point of those congruency postulates was there's only one way to put a triangle together with those measurements, so I don't really have to do any work here. There is one triangle possible. And, some of the other postulates here, just for refreshers, are angle, side, angle, 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 side, and side, 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 and you may as well throw HL in there, even though that's not really going to come up unless you're dealing with a right triangle, hypotenuse leg, right? But, those are some old things there maybe you haven't thought about in a while. Okay, let's go to another problem. So that was easy. So you don't always check what you got first. You might not have to do any work if you have a good sense of geometry. So let's see, what are we given here? And we are given angle B, angle C. We're given angle B is 74 degrees, angle C is 28 degrees, and side C is 10. And you are given two angles, and it doesn't even really matter which side you're given, except unless you're doing some kind of geometry proof. But you are given an angle here, and a non-included side, not the side that goes right in between them. So what you have is you are given angle, angle, and the side that comes after, and that is another postulate. That means there is only one triangle possible. If I gave two different students protractors and rulers and said go off in a room and create a triangle with these measurements, they would come back with the same exact triangles, because there's only one way to put these together. Okay, so another classic postulate from geometry. And here we go. Let's check out. You may be looking at this already and saying, ooh, in terms of sides and angles, what are we given? And you might be saying, I know this one, I'm already done. But one thing to consider here. So we are given side B is 74, side A is 28, and side C is 10. So we are given three sides. So you might be tempted to say, hey, that's side, 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 and that is definitely a way to prove two triangles congruent, so it's one triangle only. But with side, 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 three sides, you do have to make sure, in this case, that you can actually build one triangle with those three sides. And that means, does it satisfy the triangle inequality? And if you are already thinking about that, good for you. But that means that the sum of any two sides must be greater than the third side. That's the triangle inequality. So, meaning take your two shortest sides. If you want to see if it works for any combination, you try it with the two shortest. If I add those together, 10 plus 28, are they greater than the third side of 74? and they are not. It's not even close. And I used an exaggerated kind of measurement here. So that would be a no, and that means there's 0 triangles possible with these measurements here. If you tried to actually build this side of 74 would be so long compared to those other two sides. You know, this side being 10 and this side being 28. They wouldn't be able to touch and close it off and make a triangle. So if you've got side, 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 just make sure it satisfies the triangle inequality of sides. Okay. So you see where we're going here. We're given 3 sides here, 3 sides. Hey, side, 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 does it satisfy the triangle inequality? Take the 2 shortest sides, 18, 24, or sorry, 18 and 14, and is that greater than the 3rd side, the biggest side? And that is 32, and that is, of course, greater than 28. So that is a yes, and that means our side, side, side postulate could be applied. That means we have 1 triangle possible. It is possible to make 1 triangle with these 3 sides and 1 triangle only. That's it. Okay. So that was all just basic geometry. Didn't really use any real trigonometry here. But now let's look at these here. We are given angle B and 2 sides. Angle B is 74 degrees. The side across from it is 14. And side C is 18. So I'm going to put that right here, making that angle A. Now take a look at what you're given here. This is that ambiguous case of side-side angle. You're given 2 sides and the non-included angle. So that's side-side angle, or if you reverse it, naughty word, so let that disappear right there. Side-side angle, and that's where you got 0, 1, or 2. And you might have to do a little work to tell. Sometimes you can tell right away if you're good. But a couple ways to do this, and this is where I leave it up to my students. If you watch the other video on how to actually solve a triangle in the side-side angle scenario, you might just do it that way and just try to start solving here. And that would mean trying to solve for that missing angle of C. So if that's your approach, you would start with, well, sine of C over that side of 18 would be equal to sine of 74 over 14, and let me just try to solve for C. And you know, if you've watched the other video on how to finish it off, you know the idea is see if you actually get an answer. If you do, you got to also check its supplement, the quadrant 2, for the second possible solution. So this was going to be sine of C is equal to that. So C is going to be the inverse sine of 18 times sine of 74 degrees divided by 14. So let's bring out the calculator here. Inverse sine of 18 sine of 74 divided by 14. And we get a non-real answer. And that's the calculator's way of telling you this is an impossible scenario. So this would be 0 triangles possible. 0 triangles possible. And when we did that last video, we said that's the way to think of this is what's happening is that this decimal you're trying to take the inverse sine of is 1.23. And there's no angle that has a sign that's bigger than 1. That's the biggest the sign can be is 1. So not surprising. So that's one way to tell. Here's the other way. If and a lot of textbooks teach this way, and so I don't say it's better or worse. I think it's cool. It's a geometry way. Is to take your sides and angles. So I was given this angle and this side, and some will teach to draw an altitude right down the middle. And so really, we already know the answer is going to be 0 triangles, but I'm just showing you how you could do it a different way if you like. And to find out what is that distance from that point down to that unknown side, because this is 18 and this angle 74, so that cannot change, and this side cannot change. So that point is right there. And if you try to find that using just basic Soh-Cah-Toa, that would be the sine of 74 degrees is equal to the opposite, which is that height, h, over 18. And I'm just using the right triangle I've created. I'm not really paying attention to this for right now. I'm just finding what is that altitude, that fixed altitude. And when you find this, h will be equal to 18 times the sine of 74. Bring out your calculator. By the way, I didn't mention it, but just make sure you're in degree mode when you're doing these problems, which we are. 18 times sine of 74 is 17.30. So this height, this altitude was about 17.3. And so this is the way some people will go about doing the problem, is they'll say, look, I just found this measurement is 17.3. This is 18. This side that's 14 is too short. It needs to be at least 17.3 to reach the other side. So this 14 is too short. It could never touch this side, and that's what's giving you 0 triangles. So some people like that drop the altitude straight down and then see how this third side compares to it. If this third side is shorter than your altitude, it's not going to be able to touch, and you get 0 triangles. So I don't know if that makes it click better for you, or if you just like the solve way, but hopefully you feel good that you've got a couple ways to think about it. Here's another case here, another ambiguous. And again, without doing some work here, maybe you're just sketching a random triangle. The one angle I've been given is 35. The side across from it is 87, and this side 18 I'm going to put right there. So if you do notice, when I set up these ambiguous cases, side, angle, I tend to be consistent and put my angle in the lower left and then my two sides after that. I don't put the side down here generally, but that's just out of habit. I like to kind of set it up this way to visualize. And so again, if you see this is side, angle. You're on high alert that it could be 0, 1, or 2. And if you're not sure, just launch right in and start finding what you can. Now, this was side A, side of 18, so this is angle A, and that would be angle B. So the only thing you could find if you wanted is angle A. So sine of A over 18 is equal to sine of 35 over 87. And I intentionally used kind of a really big side there to prove what we're about to do. So A is going to be the inverse sine of 18 times sine of 35 divided by that 87. What does our calculator give us? Inverse sine of 18 sine of 35 divided by 87. And you see that angle A, we do get an answer. It's about 7 degrees. So remember, when you get an answer, unlike the last one where the calculator said no real, you have to say, well, that's the quadrant 1, which the calculator gives you, but you have to consider quadrant 2. Is there a second one? And the quadrant 2 would be the supplement of that 7 degrees or the 6.81, whatever. So that would be about 173. There's two angles that have that sign, but you've got to ask yourself, could 173 degrees, could angle be 173 degrees in a triangle that also has a 35-degree angle? And no, because those two would add up to be more than 180. So this second one is too big. That means only one solution, so one triangle. Now here's what some people are going to say using the altitude method. They're going to say, look, I didn't even have to do any work in this problem because no matter what that altitude is, I know it's less than 18, right? Because you have a right triangle here, and 18 is the hypotenuse. So that height, that altitude is going to be less than 18. And this third side of 87 is definitely longer than that, and it's longer than 18, so you're only going to be able to make one triangle. If you were to try to swing it like a pendulum here, that would be right out here. If you try to draw this to scale, it would be like, that would be 18, that would be 35, and the 87 would be so much longer. It would be, you have to stretch this bottom out to there, but you can make one triangle from it. So as long as that is longer than this altitude, you know you're going to be able to make one triangle. But you can't have two triangles because this is a longer side than this. So this angle, 35, must be bigger than angle A. Angle A can't be obtuse. So I really didn't even have to do any work here because I knew, or should know, that the obtuse case would never work for this. And this was so long it was going to be able to touch. So you could do that. Whenever this side is bigger than that, it's going to be one triangle. Again, and that's if you're setting it up in that way, the side-side angle like this. But again, if you have trouble visualizing, just do the law of sines and proceed and see if it works, you know. And so here's one more here. Okay, so here's our, again, I'm just kind of starting as if I don't really know anything. This is angle A, 35. Side across from it is 12. Also given side B, I'll put it right there, which makes that angle B, which makes this angle C. So I've given you, again, a side-side angle scenario, two sides, the non-included angle. You're not sure? Let's start doing the law of sines. The only thing you can find is angle B. Sine of B over 18 is equal to sine of 35 over 12. Take the inverse sine of 18 times sine of 35 divided by 12. Now, before I go to the calculator and actually type it, let's think about the geometry here. If I were to drop an altitude down there, you know, to include along with my 35-degree angle, I do know that this has to be less than 18. Okay, so I'm not sure how much that's going to be. Is it going to be like 15? Is it going to be 10? Is it going to be 9, 8, 7, 6? So this 12, because that's shorter than 18, it's difficult to judge how that 12 will compare to this height here. So if this height ends up being, you know, 13, this 12 is going to be really too short. It won't be able to touch this side, and you'll get 0 triangles. Unlike in the last problem where, you know, this was like 87 and it was clearly bigger than this, so it was already going to be bigger than this. So this is the one where, you know, you might have to do a little work. But one way is, like we said, just start doing the law of sines and see if you get a solution. So inverse sine of 18 sine of 35 divided by 12. And you get about 59 degrees. And I'm just rounding to the nearest whole number just because I'm trying to tell 0, 1, or 2. So you got one solution from the calculator, so you know you're good. But what about quadrant 2? You know, the supplement of 59 degrees would be 121 degrees. But is quadrant 2 a viable solution here? In this triangle, could this angle be 121? Will these two angles still be less than 180? And in this case, it will be, which means this is a valid solution. So that's going to be 2 triangles. So that's the way to tell using the law of sines. If you like to use this kind of altitude method here that some teachers like, some textbooks like, and you know, I like, you just drop that altitude down. You know, you don't have to use the law of sines, but you find what is that distance, that fixed distance. Sine of 35 is opposite over its hypotenuse, and I'm focusing on this right triangle here, so 18 is the hypotenuse in that. And so that altitude, that height would be 18 times the sine of 35. And what you get is about 10.32. So just let's think about the geometry of what this means. If that altitude is about 10.32 and this third side is 12, that means it's longer than that 10.32. So if I were kind of dangling this side of 12 straight down, it's longer than 10.32. So it's going to be long enough to touch, but it would like dip below a bit. And if you swing it like a pendulum, you can get one triangle right here. And notice that's the obtuse triangle. That's the one that's going to have a 121-degree angle. But you could also swing it right here, or, much like it's drawn right now, and that would make B be the acute angle, 59. So if you get that this side is in between these two measurements, that means it could be fit in between those two, and that means you get two triangles. So a lot of people kind of like that comparison there of just find this and see how the third side measures. If this third side is less than this altitude, it's 0 triangles. If it's in between these two, it's 2 triangles. If it's bigger than this third one, well, I never even needed to find the altitude. It's going to be only 1 triangle. So I like all that stuff. I just think it's great to know all these ways. It's all this so much geometry packed in here, and it's just a really cool unit. So that's my thought. Hopefully I gave you a good variety of problems and some different techniques and properties to think about to help you see that. So if you got any questions, let me know. Otherwise, keep working hard and hang in there, kids.